Welcome to solverfy.
They asked us to derive an equivalent circuit for the system that's shown in the figure, which is just a block restrained by a spring and a damper and with a harmonic force acting on it. So our equation of motion, if we go through Newton's laws, we just get mx double dot plus cx dot plus kx equals f naught cosine omega t, where this is the applied external load. Now, the equivalent circuit, or the differential equation for the response of an equivalent circuit, where Q is the charge. So we have the inductance times the second derivative of charge, plus the resistance times the first derivative of charge, plus C is equivalent to 1 over the or K is equivalent to 1 over the capacitance. And again, this is a capital C, this is a little c, so this is damping coefficient, this is capacitance. So notation is kind of colliding here, and then Q is the charge. And then we have the external force in here, which is basically a power supply, an AC power supply with a frequency of capital omega and an amplitude of E naught. So the circuit would be just a loop, an RLC circuit with an excitation, with a power supply on it that's creating an alternating current. And then we have it going through the inductor, and then through the capacitor, and then through the resistor, and coming back. So this would be the equivalent electrical circuit that would behave like this mechanical system does if you had these values all proportional. Again, you would wind up scaling these, because here you divide through by M, here you divide through by L, and so for a given inductance, because again, capacitors are usually very small, and the magnitudes are usually quite different. But if you scale everything appropriately, you'll get the same response.